right, so here we have a Mongo client. Let's where we have manually interacted with the database. Instead, now let's try and do it programmatically from within Node.js. Right, we'll create a small Node.js server and let's start interacting it from within the code. Right, this is equivalent to what we've done in MySQL. Right, first we spent a couple weeks talking about SQL and interacting with the database manually, and then we switched over interacting with it from within Java. Right, we wrote a whole bunch of Java code and JDBC to talk to the database from the program. So let's stop this and let's see where we are. So we are in 5200. Let's create a small application where we can start interacting with the database. Okay. So to do that, let's make a directory here where we can work on stuff for the lectures. Let's go into lectures, and let's create a brand new project in here. I'm going to use Angular's CLI to create a new project. So this will be maybe employees. So this is going to take a bit. You can install the Angular command line interface from here. Angular IO. And getting started is fairly simple. You do an npm install -g Angular CLI. Once you have that, you can just start creating projects in Angular. ng new, and then the name of your application. Right? This is exactly what we've done. Right? We did ng new, and then the name of our application. Ours is employees application. Let's see, is it done? It's taking a little while. So from within the application that is building, it installs a small server, right? A Node.js server that we're going to be using to run our application from. Right? I'm going to start opening it using one of my favorite IDEs. You can certainly use other IDEs, Sublime or Eclipse or IntelliJ or any one of these. So I'm going to open up the project and say open, and I believe we put it under NEU under CS5200 lectures and employees. There it is. I'm going to say open. Okay, there it is. So in here, it creates quite a few pieces of files. Mostly, we're not going to be touching most of these. We're going to be creating our own. So in here, we're going to create a little piece of code that is going to allow us to start communicating with the database. All right. So let's see. I'm going to create here a directory that is going to contain everything that we need to talk to the database. Right? So let's see. Let's do the application. We're going to put it inside of the server side of our application. We're going to put it under a directory called server. And in here, we're going to create a couple of files. And here we're going to create maybe app.js. Right, and here's going to be the entry points of our application. In here, we're just going to have just simple JavaScript. Right, it's just simple JavaScript. We can write everything we could do on any JavaScript we can run on a browser. Most of it we can also run here on our desktops. Okay, for instance, I can just write console log hello world. Right, and we can run it from within our terminal here. Let's see, where are we? Let's see, we are employees, and let's go into our server application, and we have our app.js directory there, app.js file, and we can just run it. We can say node space app.js, and indeed it says hello world. Okay, Node is a JavaScript interpreter, and that's all it really is, right? It's a JavaScript interpreter, right? That allows you to execute JavaScript on the desktop. Okay, that's all it is. That is all it is. Because typically when you think JavaScript, you think browser, right? This is a piece of software that is running on the browser. Node allows you to run JavaScript on a desktop. Obviously, there's some differences on what you can do when you're running on a browser instead of running on a desktop. On a browser, you have a user interface. We have menus. You can pop up alert boxes. You can draw things on the screen. Here on the desktop, you don't have any of that, right? You can't. There is no UI, right? But you have many things that you could not do on the browser. You could do on Node.js, right? On the desktop, you have access to a file system. You have full access to a network, unlike browsers. Anyway, so what we want to be able to do is connect to that database we're running, MongoDB. So let's do. How do we do that? So to do that, we're going to be using a library called Mongoose, Mongoose.js. It's somewhat like JDBC, right? JDBC is a library that abstracts the underlying database, okay? And it gives us a vendor agnostic way of communicating with the database. So it's an abstraction layer on top of the database. Mongoose is the same thing, right? It creates a thin layer of abstraction on top of not any vendor, but specifically MongoDB, okay? But it is an abstraction layer indeed. For instance, one of the things that we lose with Mongo, like schemas, right, like validation, all those things that we lose in Mongo, Mongoose provides to us, right? Support for schemas, support for validation, somewhat of a support of foreign keys, primary keys, something that looks like that. Another big thing that we lose in MongoDB is joins. There are no joins. Right? There's no such thing as joining two collections, right? And where these things match, retrieve data from some fields from one of the collections and some fields from another collection. There's no such thing in MongoDB. Mongoose brings back some of that, right? Again, with a thin layer of abstraction, it brings back some of that back. So let's start playing around with this. It all starts with these first 3 lines of code. Okay, so let's see. So these 3 lines of code, what they do is, first of all, they load the Mongoose library. They load the Mongoose library, but we don't have the Mongoose library. We never installed it. Okay, so we better install the Mongoose library. So let's install it from the terminal. Okay, from the terminal. Let's go back. Are we in the right place? Yes. We're going to install the library, the Mongoose library. We can do an npm install. npm is the equivalent of Maven, right? It's a package manager that loads library from the cloud, right? Copies them locally to your machine, right? Recompiles for your particular infrastructure, particular operating system, right? And it copies, and then you have the libraries installed locally. So npm install, we're going to install Mongoose, and -- save is so that it's going to keep track of all the libraries that we're dependent on, right? So that when if you ever deploy this on a hosted environment, right? That hosted environment will understand what are all the dependencies, right? So it'll download and install all the libraries that you depend on. So let's do that. It will install Mongoose so that we can start talking to the database. And this is taking a while. All right, so notice it's going out to npm, and it's downloading all the libraries and copying them locally and compiling them and linking them for my operating system. Right. All right, there we go. It's done. The next line of code, so now this line will work, right? Now it's going to load the Mongoose library using a require function that's specific to Node.js that loads libraries. This is like very much like an import, right, or an include. Here it connects to that database. You need to tell the name of the database you want to connect to. In our case, I believe it was CS5200. I think that's the name we gave it, CS5200. Okay, and it's connecting to our local host, so 127.0.0.1, or you would give it the IP address of wherever your MongoDB instance is running, right? Anywhere in the world, right? It can connect to, and it's using this promise library that we're going to be using in a minute, so that it can connect to the database in an asynchronous fashion, right? All right, great. So how do we do this? Well, we would like to connect to that to data. We already have some data in the database, and we know it's a couple of employees are being stored in there, right? So first, before we connect to the database, we need to create a schema, right? Remember that we don't have schema. MongoDB doesn't support schema, but Mongoose does. Mongoose allows us to declare these schemas and give it and explain what the structure of our data is, right? So let's do that. Very much like you would declare a class in Java, right? Or the way you would declare a schema in XML, right? That has a particular structure for the data that you're storing and you're retrieving, right? Same thing here. Let's see. Let's create a schema, an employee schema, and we can do a mongoose.schema and describe what the structure of the data is. And right now we have a username. We have a password. We have a first name, thank you, and we have a last name. Okay, that's all we have for now. Let's keep it simple. Once we have that, we also after we tell it using this JSON object is explaining, right, describing what the structure of our document is. Then here you can configure a couple of other things. One of the things that you can configure is that what collection is this being stored currently, right? Right now, let's see. If we go back to Mongo, and we can show the we can use the what was it, CS5200. We can show the collections. Right now we just have the employee collection, right? So we can configure and say the collection where all this data is being stored is in a collection called employee, right? Oops, this is a JSON object. Sorry, JSON object. The collection is called employee. Right? All right. Now that we have that, the next thing that we need is an employee model. The model is going to be the object that is going to allow us to start interacting with the database. Right? It's going to allow us to send commands to the database just like we would if we were at the command line. Right? About being able to create new documents, find documents, update documents, remove documents. So let's do that. Let's create a model. So we'll do a mongoose model, right? And this will allow us to register this model, give it a name, right? A logical name for us, right? So that we can refer to it at anywhere in our code. So we'll call it employee model. This name needs to be unique across the entire application for an instance of a Mongo database, right? So in this case, we're registering that with the Mongoose infrastructure, and we're telling it that our model is connected to this employee schema. So when we use the employee model to create new documents, to retrieve documents, to instantiate things from the database, and instantiate back into memory, into RAM, right? It will always validate against the schema, making sure that it's writing the correct structure, that it's reading the correct structure. Okay? All right. Great. So we can start interacting with the database. One of the things that we'd like to be able to do is retrieve an employee. Right. So let's do that. We can retrieve and do exactly the same exact functions, right, that we used it manually, right, of retrieving data. .find allows us to do that. .find, just like as this word db.employee.find, very, very similar. So find can take an argument. Now find is an asynchronous function, right? Notice that our Node.js server or Node.js file here is running in its own little process and needs to communicate with a different process, right? Where the Mongo database is running. Right? These are completely two processes that need to talk to one another through a network. Okay. Well, in this case, they're both running on my machine. It's not actually necessarily needed to go out to the network, but at some point these will be running in different machines, right? One of them might be running on AWS or Heroku or wherever, right? And the database might be running somewhere across the world. Okay, so yes, so these indeed could be long network connections. So the communication, it needs to be asynchronous. The communication is asynchronous, and our JavaScript is a single-threaded. Node.js is a single-threaded environment. There's only one thread of JavaScript running at any one time, and we can't risk having that one single thread block and waiting for this server network connection to come back. Instead, it uses a callback function where it's going to be notified of the data coming back. So we can do function, and this function we can receive either an error message if something went wrong in the connection, or the actual data that comes from the database, and we can print out the data that is coming from database data. All right. Okay. Let's see. Let's try this out. Let's run this from the terminal. See if this blows up. Let's run this. And it didn't work. Wait, what? Employee app.js. Is that what we called it? Oh, it's somewhere on, no, it's not here, right? It's, let's see, node, I think maybe server, and then app.js. There it is. All right, notice that it went out to the database server, and it came back with, notice, an array. See that? An array of objects, the objects that are actually in there, right? It's the same objects we would get if we did this manually, but the difference is that we did this programmatically, right? We can do a find, there they are, right? It's the same data. Everybody okay? But it returns as an array of objects. All right. Okay. Let's improve on this a little bit. Maybe let's put this inside of a function. We'll put we call the function find all employees. All right. And let's put this this call here, and then we can just call it, right? We can say find all employees. We can call it. So now it's programmatic. We can just use it from anywhere we want to, from within here. Okay, find all employees. The other thing that we're going to be improving on this here is that this notation, this syntax, is a little bit antiquated, right? It's a little bit hard to read, right? So instead of using this syntax, we're going to use an alternative syntax, okay? And one of the reasons that we're going to introduce this syntax is that notice that we have a function being passed as an argument, right? It's a nested function inside there. Yes. Now, if we need to string together several database accesses, right, that need to be synchronized. So, for instance, I might need to first insert, then find something, and then update, and then save it, right? If you need to put together several of these commands one after another, right, that need to execute in that particular order, they would all be nested inside of each other, right? They would be nested inside of it, so it would be very, very hard to read, okay? So instead, we're going to be using an alternative syntax. We can just do a return here. We're going to do a return, right? Now, the first thing that we would think here is that, ooh, that's nice. That's a much easier way to read this, right? We would expect that this function is returning what? Well, it's returning this array, right? This array of objects. That's our intuition. That's how it's being read. So you would expect that you could do something like this: var employees equal find all employees. Yes? Unfortunately, it's not that easy. Right? What we actually get back is not the actual array of employees. Instead, what we get back is what is called a promise. We get back a promise. Right? Remember, all this communication is asynchronous. Right? If this would work, if this worked, right, this would not be an asynchronous communication. Right? This return would have to first wait for this to come back, have actual data, the actual array, right, of documents, right, then return it, and then this whole thing would have to be a block, right, would have to be a synchronous call, and then we would then assign the right-hand side array of objects to the left-hand side variable, yes? And so that would be a synchronous call, but this is not how it works. Instead, what happens here is that this, this find method sends out the request to the server, to the database server, and then it does not wait for the database to come back. Instead, it just keeps going. Right? It keeps going, and what this actually returns is a promise. A promise that that at some point in the near future, hopefully, right, I'll get back to you. Right? I'll get back to you with the data. Right? You just need to give me a mechanism so that I can notify you that the data came back. Right? I need you to. So instead of employees, actually what we get back is a promise. We get a promise, and that promise we can register. We can register a callback. We can say, here's a callback function, right? That at some point in the future you are going to invoke, right, and pass me the response from the database, right? And then I can do a console log, and then look at the response. All right, okay. So kind of we've changed a little bit the syntax, right? Instead of providing the callback inside, right, of the find, we brought it outside. Right? We brought it outside of the of the function. What this is going to allow us to do is much more. It would be easier, right? If we need to invoke several of these one after another, if we need to change several calls to the database, right? It'll be easier to read and write them from left to right, from top to bottom. So let's run this. Let's see what it looks like. We're going to do a terminal, and it looks exactly the same way, right? It behaves exactly the same way. Everybody still with me? Okay. All right. And notice that obviously, if we would refactor this, a better way to rewrite this, right, is not to have this promise variable, this temporary promise variable in the middle, right? We could rewrite this way. Just remove the promise and just have the dot here. This is an equivalent writing of the same exact thing, right? This function, right, returns the promise, and then we can just call the then on it. Yes? Okay. So we can just rerun it, right? And it looks exactly the same way. Everybody good? All right. All right. So let's write a couple other commands here. Right? Not just find, but let's write several other useful commands in here.